Hello students, my name is Teacher Mark, your science teacher. Now, today we're going to study about gases. Properties of gases. The properties of a gas are almost independent of its identity. Gas molecules behave as if no other molecules are present. They are compressible, low density, expand to fill a container, form homogeneous mixture. Let's start with compressible. These are the picture or diagram about highly compressible or slightly compressible. Here you can see in the highlights that gases are highly compressible, while air pressure in liquid slide, they are slightly compressible. So the comparison about liquid and gas are highly compressible. Let's proceed to density. Gas are very low density compared to water. The reason is because gas are no shape. And water can have shape through the volume of the molecules. So gas are low density. Now let's proceed to the container. Here the picture of solid has fixed shape and volume, while liquid takes shape of container, forms horizontal surface, has fixed volume. Here gas expand to fill the container. You see the solid liquid gas comparison about filling the container. Now let's talk about the homogeneous and heterogeneous. We know that gas are homogeneous because we can see only one color because of the molecules. In heterogeneous, you can see different colors. Homogeneous, the properties is only one. Now we understand about the properties of gases. Compressible, low density, expand to fill a container, and form homogeneous mixture. Compressible, low density, expand to fill a container, and homogeneous. Now, let's have an example about the comparison of liquid and gases about water. Think about the 1 mole of water, which is 18 grams. According to here, 1 mole liquid water occupies less than half the volume of the golf ball. Let's see. This is the example of the pictures of the golf ball. According to here, half of the volume. So here you see the half of the volume of the liquid of 18 grams of water. Now let's proceed to 1 mole of water vapor, temperature 20 degrees Celsius or 1 atm, 1 atmospheric pressure, occupies more than the volume of 3 basketballs. So you see 3 basketballs. We need to draw pictures of basketball here. 1, 2, 3. 3 basketball. That is the atmospheric pressures of 20 degrees Celsius of 1 mole of water vapor. So let's make a beautiful ball here. this is a basketball balls. Okay, 3 basketballs. So we have 1, 2, 3. So here we have golf ball. Example, half only. Okay, so that is the comparison about liquid and gaseous water. This is the container. This one should be 1, 2, and 3 balls. Okay, so we have pictures only. Now let's proceed to comparison of the 3 states of matter. Here we have solid, and here we have liquid, and here we have gas. Solid have fixed position, and gases there is no fixed position, while liquid is dependent on the shape of the container. Now we're going to use the formula of pressure, force per unit area. So the formula of pressure equal force divided by area. The unit is Newton for force, and the unit for pressure is Pascal or PA, and then Newton per meter squared. So we have a standard of pressure here. We have 1 atmospheric pressure is equal to 100,000 and 1,325 Pascal, and this one, and this one, and this one, this one. They are exact numbers of the atmospheric pressure.
Hello and welcome to 90s. In our last video we explored what pressure is. We learned that it's a way of describing how intensely a force is being applied, and that it's calculated by dividing the force by the area it's being applied to. Take this box for example. It has a weight of 80 newtons. The area of the box in contact with the tabletop is 2 square meters. You can see here 1 meter times by 2 meters. Now if we substitute those values into our formula here, we can work out that the pressure exerted by the box on the table is 80 newtons divided by 2 square meters, which equals 40 newtons per square meter. Something that we didn't cover in our last video is that the unit for pressure is Pascal, and that's named after the French mathematician Blaise Pascal. 1 newtons per square meter is equal to 1 Pascal. So here we can say that the pressure exerted by the box on the table is 40 Pascal. Something else that we learned in our previous video is that the same force can exert different levels of pressure depending on the size of the area it's being applied to. So take this pin for example. At its very tip, it has an area of approximately 0.0000025 square meters. That is, it's really, really small. Now imagine you were to apply exactly 80 newtons of pressure to this end of the pin, that is the same force that the box was applying to the table, and that the entire 80 newtons was all transferred through to the pinpoint. Let's calculate the pressure this pin would then be exerting on the table. Here's our formula again. Pressure equals force divided by area. Let's substitute the values into the equation, so 80 newtons divided by 0.0000025 square meters, and you'll probably need a calculator for this, I know I do. Okay, here we go. Wow, 320 million Pascal. That means that the same force, that is 80 newtons, is able to exert a pressure that's 8 million times greater if it's being exerted by a pin compared to an object with the area of that box. 8 million times greater. Oh, amazing, right? Now you may be wondering, why have we used square meters as our unit here if the area is so small? You could use other units like square millimeter and say that the area is, for example, 0.25 square millimeters. If you were to put that into your calculation, that's no problem. You just need to remember that the answer you would get would be in Newton per square millimeter, and that it's not the same as a Pascal. Only 1 Newton per square meter is equal to 1 Pascal. In our next couple of videos, we're going to be looking at a few more practical examples, but for now you just need to remember that pressure is calculated by dividing force by the area it's being applied to, that the typical units used to describe a pressure is Pascal, and that 1 Pascal is the same as 1 Newton per square metre. Remember, if you're given anything other than these units in a test or an assignment, you'll just need to make sure that you take it into account in your answer. We hope that you found this video useful. If you have, please like and subscribe to the channel, and check out the written tutorial in the link below. If you're able to spare a couple of pennies and become a patron, we'd really appreciate it. Every little bit counts. Thank you, everyone.
Now let's review about how to use this formula, pressure equal force divided by area. Here we have examples of worksheets about pressure. Now teacher will give you a work to answer this question. Teacher already give the given formula and solution. For example, here the given we have 800 Newton for force. Then we have 2 meters squared here, square meter. Then the question is, what is the pressure? So using the formula of pressure equal force divided by area, this formula, then you can make a solution. So 800 divided by 2 meters squared or square meter, then we have 400 Pascal. Pressures equal 400 Pascal. So now teacher already give the given. You need to write the formula and write the solution. So this question is 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Okay? So please answer the worksheets to review how to use the formula of pressure. And give your paper to teacher Patricia. So thank you so much and have a nice day.